In Learning Objective A, we're going to talk about computing expected counts of events. So what an expected count is if an outcome in an experiment has a probability p, then in n trials of the experiment, the expected count of the outcome would just be n times p. Let me give you an example. The probability in an experiment, let's say we're tossing a 6-sided die. What's the probability of getting a 1? Well, 1 out of 6. What if we did this trial 50 times? How many ones could we expect to happen in 50 tries? Well, you take the count times the probability, and what you're going to get is about 8.3. So now be careful, this is a theoretical number. Never could we roll the die 50 times and get 8.3 ones to show up. This is just a theoretical expected count or an average. So let's look at this one. A current estimate for the proportion of left-handers in the population is 9%. What is the expected count of left-handers in a classroom of 36? Well, easy enough. N times P. The count is 36. The probability is 0.09. You compute that, 3.24 left-handers, which again doesn't seem logical, but that's the answer. Do not round this up to 3 because this is the much better answer. Another one. On Earth, assume the wet season is 125 days with an 85% probability of happening and 240 days with a 10% chance of happening. What's the expected count of days of rain per year? Now this one's a little bit mixed. So we're going to have that it either rains or it doesn't rain. So remember when we hear the word or, what that means in probability theory. It means to add. So what you need to do here is take your two expected counts and just add them together. So 125 days, there's an 85% chance. And then 240 days, there's a 10% chance. If you add this together, in a year, we would expect rain to happen 130.25 times in the year. This example, suppose a town has about 25,000 adults in its population. If the unemployment rate in the town is 5% and you sampled 200 adults from the town at random, what is the expected count of unemployed people? Now, this one, again, it's just n times p, and the p we can tell is 5%. What is the n? Is it this or is it this? And I will tell you, n is for the sample size. So they're just trying to trick you here. Don't use the 25,000, just use the 200. In that sample, we would expect there to be 10 people.